Okay, that's the specific reaction we're going to talk about. Let's see the mechanism. So the amide will attack the hydrogen. The lone pair will fall back into the carbon to form the anion. Then you can take your formaldehyde, and you form this alkoxide anion. So what's happening here is the electrons from the anion attack the carbonyl carbon, and the pi bond from here kicks up as a lone pair onto the oxygen. So it's a really cool reaction. Lone pair attacks, pi bond kicks out to form the anion. Then hydronium attack here to there, and you form the product. So what's happening here is the alkoxide, the anion deprotonates hydronium, the electrons fall back on, you form a molecule of water, and you get your desired primary alcohol. So to make primary alcohols with this mechanism, use formaldehyde. Now all we got to do to make secondary alcohols is use another aldehyde that's not formaldehyde. 5, 4, 3, 2. So that's how you make primary alcohols. Let's take a look at how you make secondary ones. So we saw how to make primary alcohols. Now we're going to see how to make secondary alcohols. For primary, you use a specific aldehyde. You must use formaldehyde. To make secondary, just use any other type of aldehyde. So it can't be formaldehyde, else you get primary. So let's use the same acetylene or same alkyne. And I'll show you a different way that we can write it. Step 1. Step 2 will be the aldehyde. Let me give that a little bit more space, please. One moment. Thank you for your patience. So there's my aldehyde. And then hydronium. So you probably haven't seen this yet. Well, maybe not this many steps. What you can do over an arrow is just write your steps. So step 1, step 2, step 3. So in other words, this is added to the starting material, the reagent, and magic happens. And then whatever the result of this magic, this is added to it, and then more magic happens. And the result of this magic, you add this to it, and then other stuff happens. So it's a sequence of events. First you do this, then after the chemistry happens, you do this, and then after that chemistry happens, you do this, and then after that chemistry happens, you do that. That's what this arrow is saying to me. And that's what it means. It's just a shorthand way of writing out chemical reactions. And there you go. There's the product. So what's the mechanism? That's what we want to figure out. So let's go up here, draw out the NH2 negative. And of course, we've seen this before. It just deprotonates. All right. Now bring in the aldehyde. Attack the carbonyl carbon. And that will give you the alkoxide. And then throw in the acid. And that gives you the product. So let's walk through this mechanism real quick. Lone pair from here, a lone pair from the base deprotonates the alkyne. So lone pair attacks the hydrogen, electrons fall onto the carbon. The resulting anion, electrons will attack the carbonyl carbon. The pi bond goes from being a bond to being a lone pair on the oxygen. Then one of the lone pairs on oxygen will attack the hydrogen of hydronium, kick the electrons from the bond back to form water. We're giving you the resulting secondary alcohol. So that's how that works. Now you'll notice from the primary alcohol to the secondary alcohol, the mechanism was exactly the same. The arrows didn't change. Nothing changed except for the aldehyde. It went from being formaldehyde to any other aldehyde. Any other aldehyde. Addition to a ketone. So let's draw another specific example. Here it has to be a ketone. So I'm just going to use acetone. It's just the simplest one. Could have been any ketone for the most part. And there you'll form a tertiary alcohol. There you have it. Again, deprotonate, first step. Mechanism is exactly the same as you just saw in the last two examples. Deprotonate to form the anion. And then draw in the ketone. Lone pair attacks the carbonyl carbon. Pi bond kicks up. Form the alkoxide ion, which of course hydronium will protonate. And you form the tertiary alcohol. So that's the mechanism of how these additions to carbonyls work. Pretty cool, pretty neat way to make carbon-carbon bond and form an alcohol.